in this? See, like, if you want, I'll tell you how to calculate the points of discontinuity. You equate this 2 times of 2x minus 3 whole square to 19. Why 19? Because 19 is there in the range. There you get only one value of x in the interval -1 to 0. Clear? So then equate to 20 another value, 21 another value, 22 another value, and so on, going till 49. For each interval you have only one value. Reason is it is decreasing till 3 by 2. From there only it will increase. Clear? Understood? Only one value you have. Same thing that side also. 2 into 2x plus 3 whole square. Range is 18 to 50. So there are 31 integers. Equate 1 by 1. If you want, you will get for every integer the value will be different. Understood? Any other doubt? That's why I am saying, like, if there are 31 integers in the range, then there will be 31 discontinuous points in the domain. Understood? There are also 31 integers in the range and 31 discontinuous points in the domain. Clear? See, like, box f of x can be discontinuous whenever f of x is equals to integer. At turning point, that continuity need to be verified. Turning point, I mean, you take sin x. At pi by 2, sin x need to be verified. At 3 pi by 2, it need to be verified. Cos x. At 0 need to be verified. It reaches maximum. At pi need to be verified. It reaches minimum. Clear? Understood? Like, in another way, in another method we have, maybe you take one example, greatest integer of sin 2x, or maybe 2 times of sin x. Let us try that one. We need to find the number of discontinuous points. Can you close the door, please? I can see if you guys submitted phones, and remaining I don't know. Maybe I'm believing you don't have phones. If I catch, I'm taking them. I'm not giving back. See, in this problem, we need to check the number of discontinuous points quiet, please. Function f of x is, I'll tell. Wait. Function f of x is greatest integer of or box of 2 times of sin 2x. If you know graph of this function, you can tell about the discontinuous things by drawing the graph. Clear? By drawing the graph. If you listen, definitely you will understand. If you are not paying attention, nothing will go inside your head. See, like, I am going to solve this one completely using the graph. First of all, to draw or to tell anything about the graph, I should know about range of 2 sin x in the given interval. A range of 2 sin x is what? In the given interval, dear students, 0 to 2. Clear? Maybe 0 is open, right? 2 is closed. Clear? So now I can say 2 sin 2x, 2 sin x belongs to open bracket 0 to 2, right? I am drawing the graph, and then I will tell how many discontinuous points we have. Pi, no, neither 0 nor pi is included in this. 2 will be at pi by 2, no? Clear? Some doubt here? So, like, now I am drawing the graph. We know sin x, sin 2x, na, it will be in this. So, like, 1, 0, pi. So once you draw the graph, next what you need to draw is like Sin 2x, 2 sin x you have drawn, no? Draw the horizontal lines at every integer. Horizontal line, like anyway y equals 0, from the beginning it is there. This is y is equals to 1 line. And then another horizontal line will be y is equals to 2, right? So now, when will be 2 sin x is equals to 1? 2 sin x is equals to 1. Sin x is 1 by 2. So x is 5 by 6. Clear? So again, sin x can be 1 by 2 at pi minus pi by 6, that is pi by 6. Now again this one, sin x, 2 sin x is equals to 2 na, sin x is 1. When is sin x is 1? Pi by 2. Understood till here? Any doubts? Anybody till here? Now I am trying to draw the graph of greatest integer of 2 sin x. Notice that 0 is not there, x equals to 0 is not there. So like now, from 0 to pi by 6 it is increasing, right? And in what interval it is there? It is there in between 0 to 1. We know greatest integer value must be 1, right? So sorry, greatest integer value must be 0. So I am drawing on x-axis. Clear? This is pi by 6. Understood this one? Like in between 0 to pi by 6, 2 sin x is in between 0 to 1. 0 to 1, greatest integer will be 0 only. Starting from pi by 6, going till pi by 2. Pi by 6 is included, pi by 2 is not included. It is ranging in between 1 to 2. If it is in between 1 to 2, greatest integer value is 1. So like pi by 6 we are filling, and pi by 2 we are leaving blank. At pi by 2 what is happening? At pi by 2 it is 2, so it will be somewhere above here. Understood this one? Now again, from pi by 2 to 5 pi by 6 it is in between what? 2 to 1, decreasing whatever it is. So I can say again 2 to 1, greatest integer will be 1 again. Clear? Any doubt in this? Understood this one? Now again, from pi by 6 till pi, it is in between 0 to 1. It is in between 0 to 1, so I can say it will be 0. Clear? So if you want, we can add this one as well in the graph. Pi by 2, pi by 6, pi 0. How many jumps are there? That many discontinuous points. So like pi by 6 is 1 point, discontinuous break is there. Pi by 2 is second one, discontinuous break is there. Pi by 6 is another one. There are 3 discontinuous points in this. Understood my point? Right? They might give you something else. So you should know how to draw it and how to break it. Like I can say one small formula for greatest integer of n into sin x. Right? N into sin x will be having 2n minus 1 discontinuous points in the interval 0 to pi, both are open. Am I clear? So like please copy this one. Any doubts is there, just let me know. Box of n sin. Below graph. See, like if you notice, this one is okay, drawing the integers line and all. In between 0 to pi by 6, 2 sin x is ranging in between 0 to 1. If it is in between 0 to 1, box will be 0. 0 na y equals to 0. I wrote here, this is y is equals to 0. Now in between pi by 6 to pi by 2, box sin 2 sin x is 1 to 2. Box will be 1. So that's what I wrote. It is 1. Y equals 1. At this point alone, pi by 2, it will be 2. So when you come down again, same, right? So again, same here. Understood? please write the conclusion, everything, or like whatever I am saying here. If you are not writing this, most probably you may not be able to recollect again. Number of discontinuous points is 3. That's what we have. So as I said, that one I'll write as a note. Maybe one problem we have in our book that you can do using that one. If 0 and 1 pi is included, that need to be verified. Clear? Open bracket only I'm talking. That's what I told, no? Pi by 6, pi by 2, pi by 6. Both 0 and pi are not included, so not checking it. Anything else? 3 only, no? Or more we have? 0 and pi is not in the interval, open bracket. So no need to check at 0, no need to check at pi. If both are included, right, at 0, again like closed bracket, right hand limit I need to check. Right hand limit and function value is 0. At pi also, left hand limit and function value both are 0 only, no, continuous only at 0 and pi. Clear? Any other doubts? Anybody? So let us write that one. F of x is equals to greatest integer of n into sin x. X belongs to 0 to pi. So number of discontinuous points. One moment. In this case, n value is 2. 2 2s are 4 minus more. Right? Anything else? Notice that n must be integer. In that case only this will valid. Natural number, not only integer, or else it will go negative. Now let us see differentiability. Clear? So like differentiability geometric meaning you would have learned in 11th grade itself in limits and derivatives. So like differentiability na unit tangent exists. Can I scroll up? Can we start that one? See, I have only one request. At least say yes and no. Understanding, not understanding. If you are sitting like idle, I don't know to whom I am teaching, to bench or like some different kind of things. Differentiability. The definition, if you want, we can say necessary condition is function should be continuous at t. Function discontinuous implies non-differentiable. Continuous implies may be differentiable, not always. That is correct. So like now second thing we need to make sure is left hand derivative and right hand derivative exist finitely and equal. LHT is equals to RHT. This should be some finite value. What is LHD and RHD? We say left hand derivative here will be limit h approaches 0 f of a minus h minus f of a divided by minus h. This is left hand derivative of the function at x is equals to a. First derivative principle we are using. Same left hand derivative we will also write limit x approaching a minus f of x minus f of a divided by x minus a. In the same way, right hand derivative will be equals to limit h approaches 0 f of a plus h minus f of a divided by h. This is about left hand derivative and right hand derivative and the differentiability of a function. If both are equal and finite value, that will be differentiable or else non-differentiable. Are we done in this? Understood the definition? So we can write some note points here. Again, converse of this statement, like maybe some important statements are there related to differentiability and continuity both. Let us write those statements and understand better if needed with examples. Hmm. Minus h should be necessary, then only. Or else both same only will. Clear? Done everybody? Can I scroll up? So scrolling up. Now these are all some important statements related to continuity and differentiability. Yes. Every differentiable function is continuous, but converse is not true. Differentiable implies continuous. Continuous does not implies differentiable. Every discontinuous function is non-differentiable, but every non-differentiable function is not discontinuous. There are some continuous as well. One moment. I am modifying it, don't worry. Please stay quiet. So we should understand continuity is necessary condition but not sufficient. Sufficient thing should be left hand derivative and right hand derivative must be equal. So as we have seen in continuity in a closed interval, differentiability in a closed interval will be there. For differentiability in a closed interval, we need to make sure first of all function is continuous in that closed interval. Second thing is at A, right hand derivative must be existing and finite. At B, left hand derivative must be existing and finite. If that is happening, we will say the function is differentiable in that interval. Clear? Understood this? Now let us write that one. Differentiability in a interval. Like what we have seen now is this is differentiability at a point. Next is differentiability in a interval. So in differentiability in an interval, we can say that function is defined from A to B. We will say function is said to be differentiable if it is continuous in closed interval A to B. It is differentiable at every point in A to B. F dash of A plus should be some finite value. F dash of B minus is also some finite value. I hope this one is clear to everybody. Differentiability in a interval. Again, as we see in continuity, if the function is differentiable in the domain, we will call that one as differentiable function. If the function is differentiable on R, like we will call that one as again differentiable function. Clear? So depending upon the function types, we will say in one line we can write all the polynomials, maybe polynomials, then trigonometric, inverse trigonometric. After that, what else we have? Logarithmic, exponential functions are differentiable in their domains. Clear? So then what else I remove? Like anyway, we have seen about greatest integer earlier, discontinuous at every integer. Fractional part discontinuous implies non-differentiable. Signum also discontinuous at zero means non-differentiable. We need to know about Modulus x, that is important. Modulus x is non-differentiable at x equals 0. Can I scroll up? Can I scroll up? So anybody writing this? Sorry. It has two tangents at 0. That's why it is non-differentiable. Continuity means no breaks. Differentiability means unique tangent. Some doubts, anybody? Differentiability of some standard functions. In one point, we'll write about all the functions. Inverse trigonometric I didn't include it because sin inverse x and cos inverse x is non-differentiable at the end points of the interval at 1 and -1. Again, secant inverse x and cosecant inverse x is also non-differentiable at endpoints. Right? You maybe if you know about the derivative of sin inverse x, you will understand what I am speaking. Derivative of sin inverse x is so if you are trying to find at -1 right hand derivative, left hand derivative at 1, again infinity, not finite value. That is the reason why we say it is non-differentiable. Even though it is continuous in the closed interval -1 to +1, at the endpoints it is non-differentiable. Am I clear? So like maybe let us add that 2 about inverse trigonometric here. Tan inverse x, cot inverse x are differentiable in R stands for set of real numbers. So sin inverse x, cos inverse x are differentiable in -1 to +1 open bracket. Secant inverse x, cosecant inverse x are differentiable in open brackets. We need to write -infinity to -1 union 1 to infinity. This is about anything we missed. Then we will write the remaining. As we know, no, none of them is included here. Sorry. If I write in that way, not included. In the derivative, what we get? We get 1 divided by mod x into root x square minus 1. +1 or -1, it approaches infinity. So like mod x is non-differentiable at x is equals to 0. Remaining all points, it is differentiable. Signum of x is non-differentiable at x is equals to 0. After signum greatest integer, no, not like that. No. Any at 0 only there is jump. At like you take greater than 0, derivative will be 0. Less than 0, derivative will be 0. At 0, it is discontinuous. That's when. What is your doubt, dear Vishnath? Huh? Fractional box least integer. This is called floor function. This is called ceiling function. So like if you have in between 0 to 1, open 0 to 1, floor function will take 0. Ceiling function will take 1. Clear? So this is about some standard functions and their differentiability. I hope you understood this one. Right? Any doubts in this? If anything I missed, just let me know. I'll add. This is box. Similar to box only. We can say z greatest integer. Right? You didn't know about this, then don't write. Erase it. Anything else? Rarely, I don't like till now. I didn't saw any problem asked on least integer. Right? So like now in differentiability, what we do is like at every point or for every function we won't be using like that first derivative principle. What we actually do there is we will directly differentiate and we'll check. For example, there is a piecewise function, and then for the piecewise function first we will check whether it is continuous or not. Once we conclude it is continuous, then to check about the differentiability, I am not going to use the definition for every point. I am going to use direct differentiation from there. I'll check. Dear Tarun Krish and that bench, I don't know what you are doing. If you are not listening, it won't be good. So, like with some example, there will be some functions defined piecewise. Piecewise, I mean non-uniform defined functions. Let's say f of x is equals to mod x. How actually I do in this? I write minus x when x is less than 0 plus x when x is greater than or equals to 0. Now I'll differentiate to check the left hand derivative and right hand derivative. No, remember one thing, when I differentiate, I won't be including the 0 here. Minus 1, x less than 0, 1, x greater than 0. I'll include 0 only if it is differentiable. Am I clear? I just did differentiation on both sides. Minus x derivative is minus 1, x derivative is 1. What change I made? 0 I didn't include it here. Now I'll tell you. Like it is continuous, no? We are sure it is continuous. Now if you check f dash of 0 minus left hand derivative of mod x at 0 is minus 1. F dash of 0 plus it will be 1. So f dash of 0 minus is not equals to f dash of 0 plus. That's why derivative does not exist. Then where you will include here or there? Not defined. So that's why we removed. Anything else? Any doubts? No. Like we can add like some, as we seen earlier, uh, what I can add here is like modulus of f of x will be non-differentiable whenever f of x is equals to 0. Clear? If we have g of x is equals to modulus of f of x, will be non-differentiable To justify this, we can take one small example. You guys know graphical transformations of this one? Maybe I'll revise it. What I should do, like just draw. No, up down illa. Just x square minus 1 we know, no? Normally x square minus 1. Draw the graph of x square minus 1. When there is a modulus, then what we should take, the below part, the part which is lying below, flip that one above 180 degree, then you will get modulus of x square minus 1. So like modulus of x square minus 1, if you draw it like it will be, this is how it looks like. What actually I did, I have drawn x square minus 1 and then this part is technically below, I flipped it above. Clear? So I can say there will be two non-differentiable points. How I am telling that there are like, we will read about this later. If there is sharp turn, sharp corner or cusp, it is non-differentiable. It is sharp turn at minus 1, sharp turn at plus 1. If you want the proper justification, I can also say this will be x square minus 1 and then it will be 1 minus x square minus 1. This is actually the function. Clear? Now, if I find the derivative of this function, f dash of x, we'll get as 2x when x is less than minus 1 minus 2x when minus 1 less than x less than 1, 2x again when x is greater than 1. Notice that at minus 1, left hand derivative is minus 2, at minus 1, right hand derivative is plus 2. Again, same thing. Clear? At minus 1 and plus 1, function is not differentiable. So that's what I did. I equated to 0, plus 1, minus 1, two non-differentiable points I have. Any doubts in this? Understood this one? Huh? So like I told, no, first draw x square minus 1. If there is any part below the x-axis, identify it and flip that one alone above. If there is no part, leave that as such. Clear? Anything else? Copy this. Let us learn about algebra of differentiability. So a table like we have seen in algebra of continuity, you can put one table, like again we'll be having f, g, and we'll be having f plus minus g, and we have f into g, f o g, like f composition g. That many columns will be there, same situation again, all differentiable, one is non-differentiable, all non-differentiable. Clear? Can I scroll up? All copied this, understood this argument. Any doubt? Don't worry, I'll tell about this corner and then cusp thing when we are studying about reasons of non-differentiability. Okay. Writing. Where? Which one? You understood? No, I just explained. I didn't say about in detail. Algebra of differentiability. F C f plus minus g f into g f o g. Please stay quiet. I request you guys to please stay quiet. When two functions are differentiable, you add, subtract, multiply, divide, take composition, we'll get differentiable. Right? So D stands for differentiability. We are talking at a point here. D, D, and if at least one of them is non-differentiable, D and N, okay, maybe N D stands for non-differentiable. I'll use N for need to verify. Right? So I can say sum or difference will be definitely non-differentiable. Right? Product may be a differentiable. Composition may be differentiable. That we need to verify. N stands for need to verify. When both of them are non-differentiable, we cannot say anything about this. Yes, ma'am. Hmm. Composition will be same only, dear. Like you take f of g or g of f, anything. Like we need to check. That is what I'm saying. I'll give counter example for these things. Please stay quiet, or else I'm going to ask you about these counter examples. Finding counter example for composition is not so easy, my dear student. I can tell you, you check whatever book you want, whatever book you are using, you don't have any counter example for composition. It is not an easy thing you will get for 1 day or 2 day. Ma'am came no? Huh? Attendance sheet before one ma'am to create. One more. So copy this table. Let us see the counter examples. Starting with one differentiable, one non-differentiable, and if I do product, I am going to get maybe differentiable or non-differentiable that need to be verified. Let me know once you copied this. All done in this. So anybody, can you think for one small counter example where we multiply a differentiable and a non-differentiable function? The product must be a differentiable at one point, not in real number. Can you think any one function like that? Online maybe. If you can think one function at any point, it's up to you. One should be differentiable, another is non-differentiable, even though the product is differentiable. Sim Simple example, mod x into x we can take, or mod x into minus mod x you take, right? So we can create it like, but we need to think that one. Okay, maybe uh, counter examples we are giving for this. In counter examples, number one we are taking as f of x is equals to x, g of x is equals to mod x. Clearly see x is differentiable at 0, mod x is non-differentiable at 0. The product f of x into g of x will be equals to x into mod x. If you break this one, you have minus x square when x is less than 0, x square when x is greater than or equals to 0. If I check the derivative, right? So how much is uh, left hand derivative LHD at 0? You will get minus 2x. If you put 0 there, you have 0. A right hand derivative, you get 2x. If you put 0 there, it is 0. No need to worry, it is like continuous into continuous. The resultant must be continuous. Clear? This is one counter example I can say. Now, Second counter example may be like for composition, one continuous, one differentiable. Second one is non-differentiable. F of x is equals to x square. G of x is equals to mod x. Clear? One continuous, one differentiable, another is non-differentiable. If I do f of g of x, we will get what? This will be mm, f of mod x. F of mod x is mod x whole square. As we know, x square or mod x whole square both will be same. So notice that differentiable, non-differentiable, the composition we got as differentiable. Any doubt in this? Now, third counter example, let us take both of them as non-differentiable. When we add, we should get differentiable. Mod x and minus mod x. See, like I am trying to make sure the function is continuous but not differentiable example. If I am adding them, I am having 0. If I am multiplying them, what we are having? Minus 1 into x square. That is differentiable at 0. Then what else we need to give for composition, like maybe two differentiable function. Like here, I thought for a day or two, but I was not able to figure out one example where both of them are continuous but not differentiable. What I did now, I did something like this. F of x is equals to fractional part of x. G of x is equals to greatest integer of x. Now, f of g of x will be fractional part of greatest integer of x. That will be 0. Clear? So this is what I have as a counter example. Understood? Right? So when both of them are differentiable, add them, subtract them, multiply them. When dividing, z of a is non-zero, and the resultant will be differentiable. Composition also differentiable. When one of them is non-differentiable, we can say about addition and subtraction, definitely non-differentiable. Multiply, divide, composition need to verify. Clear? Both of them are non-differentiable. Add, subtract, multiply, divide, composition need to verify. Am I clear? Any doubts in this? Now we can add one note point as we wrote in continuous f of x into g of x. When we can make continuous is f of a is 0, right? So same kind of argument we have, but we have extra restriction in this case. Notice that let us take a function if f of x and g of x are two continuous functions at x is equals to a and f of a is equals to 0. F of x is a differentiable at x is equals to a. G of x may or may not be differentiable. Then f of x into g of x will be a differentiable at x is equals to a. See, like this continuity rule cannot be breaked. If you are having like g of x differentiable, sorry, f of x differentiable, f of a is 0, g of x is discontinuous, the product may or may not be differentiable. Clear? One example I have given for this, x into mod x. X is differentiable, x will be 0 at 0. Mod x is continuous at 0, that's the only product we got as what? Differentiable, right? So now I can give you two examples where we are breaking this continuity even though you get differentiable, and then like you break this, you are not breaking this, you will get non-differentiable. Clear? So like I'm scrolling up. Let us take an example here. In this example, we are taking a function f of x is equals to x, maybe square you take, g of x is equals to signum of x if I take, right? So signum of x clearly discontinuous at 0. Clear? So now f of x into g of x, we have minus x square when x is 0, 0 when x is equals to 0, x square when x is greater than 0. Am I clear? So now if we are talking, it is definitely continuous. Agree with me. F into G is continuous. What about the differentiability here? What do you say about left hand derivative and right hand derivative? Left hand derivative at 0 will be, no, at 0 means 0. Right hand derivative at 0 is 0. So I can see that LHD is equals to RHD is equals to 0. Right? I have given one example where it is discontinuous and but the resultant is differentiable. Again, we can also have an example where x and then signum of x, right? Differentiable discontinuous at 0. Product is, so we have minus x, 0 when x is 0, x when x is greater than 0. Now you differentiate and check. Non-differentiable, right? So when we are breaking the rule of continuity for g of x, the resultant we are not sure. Need to be verified. When it is continuous, in that case, I can say you will get differentiable for f of x into g of x. Am I clear? Any doubts in this? Anybody? So LHD is not equals to RHD. Now let us learn about reasons of non-differentiability. What do you think about the first reason can be for non-differentiable? First reason will be discontinuous. If the function is discontinuous, non-differentiable. So second reason I am telling here, uh, sorry, uh, like that one we will say in this way. What you call is like there is no unique tangent, more than one tangent at the point. Mod x at 0, you have right hand tangent slope is +1, left hand tangent slope is -1. Unique tangent does not exist. Right? Now one more thing we will say is sharp, that unique tangent thing only, sharp corner or sharp cusp or sharp turn, they'll call anything is same. Like all of a sudden it is taking the turn. Mod x you take at 0 it is changing, no, that will be one reason. Now the last and final is vertical tangent. Vertical tangent na slope of the tangent approaching infinity. The vertical tangent is also sometimes called as asymptote, tangent at infinity. Clear? There are mainly three reasons. So there, Sujana, Sujit, what that boy name? Sujan, what you and your friend Gautam are doing there? Huh? Sorry? Don't show book and all again. I'll throw you out of that window only. If you are reading, stay reading. Not reading also. But like you try to act smart, then I should take some action. I won't say anything unless until you are not doing anything to my class. You sleep, you die. I don't mind. But like if you are disturbing, you are uh, doing something to the class, then only I should interfere in that case. So reasons of non-differentiability. So in reasons of non-differentiability, first one we can write here, discontinuous. Discontinuity at x is equals to a. Discontinuity na there is a break. If there is a break, then there won't be any unit tangent. Clear? That is first reason. Second reason is sharp turn. We will also call as corner. See, when we will be having this now, if we have more than one tangent at that point, in that case, we will be having sharp turn or something. Third one, that's what unique tangent does not exist at this point. More than one tangent. Vertical tangent. Cause spelling might be wrong. It is like turn, corner. I'm little bad in English, right? So in discontinuity, okay, cusp and corner thing, if you want, we can say mod x as the example. So this has sharp turn at 0. That's why it is non-differentiable. Clear? Vertical tangent, if you want some example, we can take f of x is equals to x to the power 1 by 3. X to the power 1 by 3 is non-differentiable because it has vertical tangent at 0. You can clearly check at x is equals to 0. Let's say I'm trying to find left hand derivative. How much is that? F dash of 0 minus maybe f dash of x. Let us find. How much is f dash of x here, guys? 1 by 3 into x power minus 2 by 3. As x approaches 0, x to the power minus 2 by 3 will approach infinity, right? So it has a vertical tangent at 0. Vertical tangent na again non-differentiable. There are three and simple reasons. Understood this one? Any doubts in this? Anybody? First reason may be discontinuity. If there is discontinuity, unit tangent we cannot draw. Second reason, a sharp turn, sharp corner. If there is sharp corner, in that case, again unique tangent does not exist. That's why non-differentiable. The third one is vertical tangent. Like as I said, left hand derivative, right hand derivative must be finite value. Clear? Right? Tan pi by 2 is not infinity. That is not defined, first of all. That's only we say there is a vertical tangent. That's why non-differentiable. Clear? Any doubts in this? And this one I'll draw it. Now vertical, this tangent I'll draw here. So this is the graph f of x is equals to x power 1 by 3 at 0. You have a vertical tangent. Okay. Any other doubts? Any other doubts? See, like now, as far as I am concerned, this is about continuity and differentiability. Now we need to solve as many problems as we can. Like there are different types of problems are there. Let us start them. Clear? Can I scroll up? All copied this. Right, in some problem I'll use graph. In some problem I might break it. In some problem, if needed, we will see and tell. No, like maybe can you ask in break time or something? In between, it won't be nice. It will break the rhythm. So the problem is something like this. Find the number of non-differentiable points for f of x is equals to, I don't know whether you have seen something like this. MAX stands for maximum, MIN stands for minimum. What I actually do, I draw both the graphs. After drawing both the graphs, if needed, I'll find point of intersection. Then which graph is lying above, that must be my function. Am I clear? So we need to find this function first. Then we should tell about the non-differentiability of the function. Am I clear in this understanding? Now, like we all know graph of mod x, we all know graph of x square. Like if we put that one here, like give me a moment. This space we are using. So this is graph of mod x, and then like one moment. Uh, this is graph of x square upward parabola. One moment. It's not coming properly. Clear? So now I need to, first of all, I have drawn it. If I want, I can easily find the point of intersections by equating x square to mod x. You solve it, you will get plus minus 1 and 0. 3 are there. So like now, notice that maximum I need, not minimum. If the graph is lying below, like uh, this is x is equals to minus 1 point. This is x is equals to 1 point. This is 0 over here. If I see in between minus 1 to plus 1, mod x is clearly lying above the x square. And if it is lying above, that must be our function. We can delete or we can remove x square portion. I am like, this curvy line means I am deleting this. So like since I want maximum, I'm deleting the below one. If I want minimum, I'll delete the above one. Clear? So like now, after that, like if you notice after 1 or before minus 1, x square is clearly lying above the x. So mod x, we are removing now. Mod x, we are removing now. After doing this, the graph looks like this. Till minus 1, it is parabola. From -1, it is mod x. Again, till 1. From there, it is parabola again. Something like this. If you see here, -1, 0, and 1. There are no breaks in the graph. Do you see any breaks? No breaks means function is continuous. Clear? Now I can see this is corner number 1 or turn number 1 at -1. Turn number 2 at 0. Turn number 3 at 1. I can see by graph there are 3 non-differentiable points. Let's say you don't want graph. You want to write in function wise only. I can write that f of x will be equals to piecewise function I'm writing. It is x square when x is less than -1 because that is maximum. And it will be mod x I'm breaking again, minus x when -1 less than 0, x when 0 less than or equals x less than 1, and then it will be x square when x greater than 1. The equality of -1 plus 1 can be anywhere because that is point of intersection. I can write equality here and I can also write equality here. Do you understand how I wrote here? Do you understand how I wrote here? Anybody there outside? They are saying something? Nothing. No, if anybody wants, no one is there, right? Do you understand how I wrote this definition? Like, see, I wrote x square here because when x is less than -1, the graph of x square is clearly lying above mod x. Clear? And I wrote this should be mod x. Mod x also have break-in. It will be minus x when x is there in between -1 to 0. This is minus x. And it will be x when it is there in between 0 to 1. Again, from 1 onwards, it is x square. Right? The equality of 0 can be given here or it can be here as well. Clear? And then the -1 or +1 equality, I can keep -1 here equal, or I can also keep -1 here equal. Both are intersecting at that point. Same goes for 1 as well. Once I done, if I have something like this, I can clearly see left hand continuity first of all. Left hand limit at -1 is how much? Can you tell how much is left hand limit? Huh? Left hand limit at -1, 1, right? 1. -1 whole square, right? So the right hand limit at -1 will be 1. No, no, I'm talking about function value is also okay, continuous at -1. Now what about 0? Left hand limit at 0 is 0. Right hand limit is 0. Function value is also continuous at 0. What about 1? Left hand limit at 1 is 1. Right hand limit is 1. So continuous yes 1. The function is continuous on R. No worry. Now differentiability. If I differentiate, this is 2x. This is -1 and next will be 1 and again 12. Now how much is left hand derivative at -1? That is -2. How much is left right hand derivative? -1 minus. Right hand derivative not equal, not differentiable. What about here at 0 anyway? -1 and +1. At 1 if I check it will be 1 and 2 here. Understood? Any doubts in this? That is the reason because it has 3 differentiable points. Any doubts in this? Copy this. This is like important one. Please conclude in your own words. I have given the explanation. Whatever you like, you write it. Come down. Differentiability. See, like you just differentiate, no? Remember, when differentiation, remove all equalities. Equalities will keep at the end if derivative exists. Right? So next to this, please write one line. Function is continuous everywhere. Next to this, please conclude that it is non-differentiable at -1, non-differentiable at 0, non-differentiable at 1. Why non-differentiable? Didn't understand. At x is equals to -1. F dash of -1 minus left hand derivative at -1. In the left neighborhood, 2x is what you have. So if you substitute -1, you will get -2. What about right hand derivative? Right hand derivative is how much here? -1, correct? So what I can say, it is differentiable? No, then what about x is equals to 0? F dash of 0 minus, that is -1. F dash of 0 plus, that is +1. Now at x is equals to 1. F dash of 1 minus 1. F dash of 1 plus, what actually I am doing? 1 plus now going here, substituting x is equals to 1. So clearly, three non-differentiable points we have. Do you understand? Do you understand? Any doubts in this? Anybody? So then do one thing. Same non-differentiable points I want. In this time, maximum not minimum of x and x cube. Same, find the number of non-differentiable points. In this case, not maximum, it is minimum of x and x cube. Two functions. X and x cube minimum. What are +1 and -1? Do that. Vijay sir came at that time. Oh, just walk by. He didn't ask, no. We are not giving maths class today. Year after not. Calculus we are in. So we need more time. So this is second problem. Find number of non-differentiable points. Function is minimum of, we have, that's all. You should know the graphs first of all. Why 3, 2 only, no? 3, 0 also we are getting, let us check. I didn't remember correctly. Ayyo, it's not coming properly. See, like continuity, no doubt it will be continuous only. Don't worry about continuity. So, like I have drawn y is equals to x, y is equals to x cube. So minimum means what did I said? Upper graph we need to delete. So like notice that this is one point of intersection we can see here, that is -1. I can directly find x equals x cube you do. This is 0. So now less than -1, if I observe here, this is y is equals to x line, this is x cube, right? So x cube is lying below, so delete x line. Now at this point till here, x cube overtaken x. So x cube is maximum. So that I need to delete. X cube I deleted. Clear? So now again from here till there, x we need to delete. So we deleted x as well. Then x cube again, that also we deleted. Now graph or function, if you want to write, we can say function f of x will be equals to x cube when x is less than -1. It will be same as x when -1 less than or equals x less than 0. Again x cube when 0 less than or equals x less than 1, and we have x greater than or equals to. Normally from graph, 1, 2, 3 turns are there. So therefore 3 points of non-differentiability. You need any argument or need proper explanation? Here you have. Clearly see continuous at -1, continuous at 0, continuous at 1. Differentiability won't be there. Understood this one? Any doubts in this one? Any doubts in this one? Anybody? No doubts? Please copy this one. What is your break time? 11? 15? 50. Hey, no breaks for this class. Don't mind. For offline students, no breaks. I think like 11:20 only. 11:20 only one break should be there. 9 to 9:50, 10 minutes break. 10 to 11:20, 10 minutes break. Then 12:50. Next class is also hours only. Let's continue this. Huh? No, no, no. I don't want any break. Like, to be honest, I'm an engineer. I like teaching calculus. So if you want to be a good engineer, you should know calculus. Clear? So I'll teach full day as well. Can I scroll up? All copied this, understood this problem. Now, some other problem, maybe this one using graphical transformation. They have given f of x is equals to modulus of x square minus 1 into mod x minus 6. I'm not going to break this one. I'll do graphical transformation from there. I will tell about it. See, like, first of all, I need to know what is graph of y is equals to f of x square minus x minus 6. If you notice, this is modulus of g of mod x. There is no doubt about continuity. First of all, mod x is continuous. So composition between x square minus x minus 6 and mod x will be continuous. Again, one more time you do. Continuous only, no need to worry about it. Now, first of all, how to get the graph of g of modulus of x from g of x? Right, for that. Uh, no, like normally you just tell me how to draw g of x is equals to x square minus x minus 6. Two real roots. Roots are real and distinct. Plus 3 and minus 2. So, one moment, please. Please stay quiet. Okay, minus 2 is the root. At 0, it goes minus 6. Something like this. This is y is equals to g of x. Now from g of x to g of modulus of x, we need to identify which lies left side of the graph, left side of the y-axis. So erase this left side part, take the mirror image of right side part. That means I need to remove this portion and flip this one 180 degree about the x-axis. Do you understand? Right? I have drawn g of x first of all, g of modulus of x if I want, right? I erased this, then flip this one, take image. If you take image, you will get. So like now it will be. One moment, please. Right? No, like here, this is g of x. Now we are drawing g of modulus of x, na? That will be g of x when x is greater than 0. G of minus x when x is less than 0. Something like this we'll be having. This point is 0 comma minus 6, and this is 3 comma 0, and you have minus 3 comma 0 as other root. Mirror images symmetric about this x is equals to 0 line. uh, One moment. W only it will come. I did mistake. One moment. I should have did like that. Mm-mm. Something like this. Hmm. Oh, it is not passing through origin only. That's what trying to get. One moment, please. So this is 0 comma minus 6. Now we have 3 comma 0 and minus 3 comma 0. So once we have drawn g of this is f g of modulus of x. Now if I am taking mod for this, please listen. Identify the below part, flip that part above. So if we flip that part above, we will be having, please stay quiet. Something like this you will get. So this is 3 comma 0, 0 comma 6, minus 3 comma 0. Now I can see how many 1, 2, 3 non-differentiable points I have. Do you understand this? Do you understand this? Sri Vishnuvardhana, what you are doing with your friend? Break I am not giving. Gone only. Maybe I'll take one class of physics also. Can I scroll up? All done in this? Any doubts in this? For everybody, I'm not giving. If you want to go, you go. I am not stopping for anybody here. Can I scroll up? All understood this one? Okay, please write the conclusion. Number of non-differentiable points is 3. What happened? Everything you are getting differentiable where? Which question? Oh, that one. Okay, we will discuss later. Hmm. Same. Why differentiable you? You should not get differentiable. You should check again. You should check again. So then, wait, please. Let us take one problem. So this is what I am expecting. See, go page number 61. Page 61. You can. Page number 61. 3 only, no? Minus 3. This point. Dark turn, no? Like here it is turning. Here again it is turning. And then here again it is turning. You go, Re. I won't stop you from going break and all. You can go break, have fun, enjoy outside. Never mind. You want, you go. I'll keep discussing. That maybe you ask, no, at 12:50 something. Which minimum? This problem. Like I already gave explanation now, dear. See, like it is x cube. Very simple, dear. Don't think much. Differentiate it. You can go for break. Don't worry. You're all crying. So you go for break. Come back as soon as you can. Right? X cube is there. X cube and then again x. If I differentiate this one, right? You are clear with continuity, right? In this, it is continuous everywhere. That argument is okay. Uh, Now differentiate it, remove all equalities, then check at the -1, at the 0, at the 1. Online students, please log into the next link. How was the paper, sir? Yesterday. Huh? Don't think chemistry out of portion difficult something like that. Huh? Yesterday. How was the paper?